Hello, pre-calculus classes. This is Mr. McAllen speaking, and today we're starting day 19 of our flipped classroom for trigonometry, and today we're going to be going over law of cosines. So, first thing we want to talk about is when to use law of cosines. Law of cosines is perfect for the use when you have side angle side given or side side given. So let me just discuss a little bit of a strategy. If you're given side angle side, the first thing you want to do is you want to find the missing side. And then once you have the missing side, then you have side, and you'd use the formulas for law of cosine that are for side situations. So first things first, let's go over what the formulas are. The first formula for law of cosines is, it's basically called extended Pythagorean theorem. So if you have given if you have two sides in the included angle given, it may fit into the 1 to 3 forms, where you have the small side c that you're looking for is equal to a squared plus b squared minus 2ab cosine of angle c. There are two alternate forms of this depending on if you're given the other sides. Make sure that you note this as being capital C, because that would be the included angle. The other two forms are b squared is equal to a squared plus c squared minus 2ac cosine of angle B. And the other form would be, if you're looking for side A, it would fit into this category where a squared is equal to b squared plus c squared minus 2bc cosine of angle A. Now, once you find the third side, then you're in the situation of side, and you would use one of these three formulas, which are also other forms of the law of cosines. These forms are, for example, if you're looking for angle C, I'm just going to put the angle sign here so you know that that's capital angle C is equal to the inverse cosine of the following fraction. And you have to make sure you enter this information right. It would be a squared plus b squared minus c squared all over 2ab. Remember, this is inverse cosine, and you're putting in the three sides. Make sure that you get the sides correctly written in there, because a simple negative sign could throw everything off. If you're looking for angle B, that would be written as inverse cosine of a squared plus c squared minus side b squared all over 2ac. And the last one, if you're looking for angle A, that would be inverse cosine of b squared plus c squared minus a squared all over 2bc. You can notice there's a pattern to this formula, and in my classes I went over how we exactly derive this, but your job for this video is to understand how to use the formulas to solve for the missing sides and angles for a triangle. So let's get to work on this first example. It says we have triangle ABC, and side A is 32, side C is 48, and the included angle is 125.2 degrees. So we'll just draw up an oblique triangle. I'll make it a little bit larger. Angle A, B, C, and that puts side A to be across at 32, side C to be 48, and the included angle, so we know we have this side angle side situation. Because we have that, and we're going to be looking for side B, we're going to use a second formula, and that's going to be b squared is equal to a squared plus c squared minus 2ac cosine of angle B. So using the graphing calculator, well, actually, I'm going to just write it out for you. So we see we have 32 squared plus 48 squared minus 2 times 32 times 48 times a cosine of 125.2 degrees. We put that into the calculator, which I'm going to move over to the side here so we can see all the work that's done. And please, with the graphing calculators that you have today, everything can be done in all one step. So please enter all the information in as one big step. The calculators can totally handle it. Make sure you edit it or you at least proofread it before you submit it. So I have 32 squared plus 48 squared minus 2 times 32 times 48 times a cosine of 125.2. Make sure you verify that that's the actual formula. So I'm just going to go back. Cosine of 125 is there. I'm just trying to, I'm pretty sure I put everything in correctly. Minus 2 times A times C, 32 times 48. And then I have 32 squared and the 48 squared. So I hit enter and I get 5,098.8. Remember, that is not B, that's B squared. 5,098.800075. And I want to show you something interesting. We want to take the square root of this. So what we're going to do is I'm going to hit the square root button. So I have the square root. It's waiting for a value. So I can just arrow up on the TI calculator, hit enter, and it will put in the whole value that was calculated, so I don't have to worry about typing that whole value in again. So take advantage of that. And now my answer is for B is equal to 71.4. I'm going to round off to 2 decimal places. 71.41 units long. So now we know the third side. I'm going to put the calculator away. I'm going to put here, but in red, I'm going to put down 71.41. That will represent that that was a side that I calculated. Now I'm left with finding my two missing angles. I have angle A and angle C. So I'm going to use one of these formulas. Remember, anytime you're using a law of cosines, you'll always either use the law of, like the angle formulas 3 times, or you'll first use a formula from the left side here, find your missing side, and then you'll use the formulas on the right 2 times to find the missing angles. All right, so let's look for angle A. Angle A is equal to, I'm going to write inverse cosine of 71.41, I'm sorry, it's B squared. I'm just going to write it out first. Actually, you can see the formula right here. So it's B squared, so it's 71.41 squared, plus C squared, which is 48 squared, minus the A value, which is 32 squared, all over 2 times 71.41 times 48. You want to put this all in the calculator at once. So again, it's very important that you understand how to use your calculator on the Texas Instruments calculators that you buy today, especially the graphing. We really want you to take advantage of a nice feature they have. We're going to go to inverse cosine, and if you do alpha F1, you'll have the N over D feature, which lets you put a numerator in as a very complicated function over denominators. So it basically resembles what you see is what you get, or pretty print mathematics. So I'm going to type in 71.41 and make sure I square that, plus 48 squared minus 32 squared. Now make sure you verify what you're putting into the calculator. You don't want to make a mistake here. If you get an answer that you're putting into the inverse cosine function that is greater than 1 or less than 1, you're going to have a domain error. So you should go back and check your work. So I'm going to put in 2 in the bottom times 71.41 times 48. I'm just going to arrow over to the right, close my parentheses, and hit enter. And I have an angle A to be 21.47. What I want you to do is do the same thing, because you need to calculate angle angle C. So use the angle C formula, and after you're done pausing the video, verify with my calculation. So pause the video now and give it a shot. Okay, classes. So or folks. So back from trying to find angle C, you could see here that angle C is 33.31 degrees. I have my computations over here with a calculator, and you can see that it's a pretty powerful method for solving a triangle. If you're given side, angle, side, you have one step to do with finding the missing side, and if you have side, side, side given, you can just jump right into the formulas on the right and find the other angles. Okay, pre-calc folks, here's our second example, and I'd like you to try to do this one on your own. Example 2 says you have a triangle, 3 sides given, A, B, and C. Solve the triangle, which means you've got to find the 3 angles. This is the case where you're given side, side, side. So what I'd like you first to do is when we pause the video, I would like you to just draw the triangle with angle A, B, and C on it and the sides represented to make sure that you started the problem right. So I'm going to pause the video now and I'd like you to draw the triangle. Okay, so we're back and the triangle is drawn and you can see that the sides are opposite their given angles and now we have to find the angles. So what I'd like you to do is I'd like you to find the angles. Remember there's 3 formulas we had from before. I'll go up and get them. And you should know these formulas as well. So let me just copy and paste those formulas that we drew out from before. Hopefully they came across okay. I'm going to just clean them up a bit so you can use them. And I'd like you to find the missing 3 angles. And then unpause the video and we should have all 3 angles displayed with their work. Okay, and we're back, and hopefully you can see from the work here that we found angle A, B, and C. You check your work against that, make sure you're putting that into the calculator correctly. And the other thing we want to check is, do these angles add up to 180 degrees? And so if you take your calculator, you do 26.38 plus 36.33 plus 117.27, we get 179.98 degrees, and that would just be round off error. So we all agree that the angles add up to 180, and their sizes should be proportional to their opposite side length. So A should be the smallest angle, which is 26.38. B should be the second largest because it's opposite the middle side, so it'd be 36.33. And C should be the largest because it's got the largest opposite side, and that's 117.27. So what I want you to do to prove that you understand what's going on here is I want you to do number 3. Again, it's another side, side, side situation. I'd like you to find all 3 angles and please report them in the form that is this video is embedded in. Good luck, and I hope you found this video helpful.